This is Alchemist Camp, where we become better Elixir programmers by building things. This video is a solution to challenge number 7, which was to build a clone of Unix's tail command. If you're not familiar with that, that's just a command that prints out the tail end of a file. By default, it's the last 10 lines, but it has an option you can pass so that it's a different number of lines if you want. We're going to call our clone of it Caboose, just so it doesn't conflict with tail, and also because Caboose is what the last car in a train is called. So we'll mix new Caboose, and we'll go into the new folder. And as before, when we did a command line script, we're going to use eScript and pass it the name of the main module, which we're going to call caboose.cli. Let's go make that. So in the lib directory, we'll make a directory called Caboose, same as our main module name, and then we'll create a file called cli.ex. We'll make a new module, caboose.cli, and the function is main, which it has to be. Take in args. Then we're going to use the same option parser that we did in the last lesson. In fact, this whole main function is going to be a lot like the last one was. So we get back 3 things from that function: parsed, args, and invalid in a tuple. Option parser.parse, and we have to give it the args we got from main. We'll name the switches that are valid. In the case of tail, it's only, in the case of this challenge, it's only the line switch. And that's going to be an integer, like 5 lines or 15 lines. And we'll throw in a help switch. And help doesn't have any arguments. If they ask for help, it just helps them. Alias, or aliases, we'll use H for help. And we'll use N for lines, not L, because the actual tail utility uses N. And now we'll call the main Caboose module caboose.start parsed args invalid. Save that, and we'll go to our main module and get rid of all this default stuff because we don't need it. Then we'll make our start function. Start, and it's going to take parsed. Going to take args, but we'll call that file name because that makes more sense in this context. And then any invalid input from the options parse. All right, now we've got a match for the kinds of input that won't let us continue with the program. So that would be like no file name or 2 file names. I'll match that right now. If enum.count of file name is not equal to 1, that's a huge problem. Or if anything comes in the invalid parameter, that's also a showstopper. So if nothing comes in on that parameter, or I should say if nothing is returned in a tuple in our CLI module, it's going to pass us an empty list. If there's anything in that list, then we have some invalid input, and probably better stop. So we'll just put bad input and a new line, and we'll show help. This function doesn't exist yet, but we'll make it soon. If that doesn't happen, then we can go on with the program. Why are these spaces? Oh, shoot. 2 spaces. And it uses spaces 2. That's really weird. It went to 4. All right. So we can go back to 2. That was driving me crazy. All right. We'll set the flags equal to enum.into of parsed and an empty map. This requires a little bit of explanation. I'll get into it in a second. And then we'll call read file, which also does not exist yet. And file name and the flags. And since invalid can't have anything in it, or we wouldn't have reached this branch, we don't need to pass that on. Okay, let's look in IEX really quickly. As you may recall, the way that the flags are passed to us is parsed, is what it's called. The way that they're passed into us is a list of tuples. So we're going to have something like lines 50, help, true, sum, flag, foo, and so on. This list of tuples, any list of tuples like this, turns into a keyword list. So, or I should say a keyword list is just a list of pairs. That's it. And it's displayed like this by default because this is easier to read, but it is just a list of tuples. And you may remember from the minimal to-do lesson, enum.into will turn a list of pairs into an object, which is truly a key value structure. So we'll run this through enum.into and then an empty object. And you can see we have this other syntax. And this is actually a really good structure to use because we'll call this our map. This is a really good structure to use because it's easy to query. So you can see there is a keyword, or there is a key called help. And an alternate syntax to do the same thing is using brackets and an atom. There is a difference between these two syntaxes, and that is if you type in something that doesn't exist, like this, the bracket syntax will just return nil, but the dot syntax will have a key error, which we don't want to have when we're checking to see if something exists. Okay, so that's why we put the flags into a map, and now let's make our other functions. So show help is, let's save that one to later. For now, let's just have it show that there is a problem. So show help, do io.puts, and this is going to be long, help always is. And we'll just say help for now. Fill that in after we've got more of the program done. Then we'll make our read file. Read file, and that only had two arguments, file name and flags. And body is file.read with a bang, so this will crash if it doesn't work, but if we can't read the file, it kind of should crash. And if this were a huge file, it would be much faster to use a stream. However, for any smaller file, this is faster, and we're probably not going to be doing this on huge files, although it's something to keep in mind if someday you do. Lines of the file are going to be string.split of the body of the file, and we'll split it on what is probably now a familiar regular expression that matches Windows new lines from old systems, and new lines from Unix. And now we've got those lines. Next is num displayed. And this is going to be 10 by default, but if the user put in a flag for lines or the alias of -n, then it'll just be that many. So we'll use a one-liner if else in order to set num displayed to that. We'll say if flags lines, and remember it has to be this syntax, not the dot syntax, since that would crash. Do flags of however many lines, else 10. And better than 10, we could use a module attribute for this. Default lines, and then way up at the top of the file, we will set that module attribute, default lines 10. Okay, and at this point, let's just do a quick sanity check, make sure everything's working. There are often a few bugs. We write this much without checking anything. Inspect. We'll just give it a tuple of file name, flags, and num displayed. All right, and we'll go to our shell and get out of IEX. We got a cd into Caboose and mix escript.build to build our command line tool. Ooh, looks like that may be okay. And then escript Caboose. And if you're not on Windows, you don't need to type in escript. This is just because there's no file extension and Windows won't know what to do with it. Escript Caboose, and we'll run it on the README. There we go. So the file is README, no flags, number of lines 10. That seems right. Let's do N50. So now lines is 50, and it's updated the number of lines to display. Excellent. How about lines and no argument? Bad input. Excellent. Lines 20 and a dash H. Actually, wait a second. I think that's just because of the dash H. Help true. Oh, we do have some dash lines 20. Okay, it actually was bad input. Okay, this looks great. So in that case, we're almost done. We just need to get the right number of lines, put them together into a big string joined on new lines, and show them to the user. So it would make sense to just do a processing pipeline. So we'll do lines and pipe that into enum.take. Enum.take takes the first n elements out of a collection, but if you pass it a negative number, then it takes the last n elements. So num displayed, and then we've got to join those lines together, and we'll join them on a /n, and then we'll just puts it to the user. And the help section is going to be a bit of text, but should be super straightforward. So we'll say usage, Caboose, file name, flags, flag args, flags, help, displays this message, and dash lines, and a number, displays the last n lines of a file, dash h, same as dash help, dash n, and a number, same as dash lines. And maybe we could make this a little bit longer. So hold down Control and Alt and hit down, And then you can multi-select by lines like that, hit escape to get back out of it. That works on Visual Studio Code. I think the same works on Sublime Text or Atom. If no flags are used, Caboose displays the last 10 lines of a file. Example usage Caboose some file.txt or Caboose some file.txt -- lines 40. All right, let's recompile. That is the README is not the best file. Let's actually just look at the file we're working on right now. So that's in lib, and it's called caboose.ex. So the last 20 lines, that showed us the help, and it did it. Yeah, this isn't quite what we want. We want help to override anything else. And it looks like we're not even checking for it here. So let's see if there's a help flag. We will just store that in something called help flag. And that's going to be equal to enum.member parsed. And it's going to be a tuple help, true. Okay, so if we get a bad file name or anything invalid or a help flag, then we're going to write bad input and showing help unless help flag do bad input, because that's the one reason we could come in here that would not have bad input, and we show help. Okay. Let's rebuild the script. Got help. Now we got the last 20 lines. That looks like what we want. How about if we just said lines and didn't have any space? Then it says bad input, and it shows us the help. Do this, it does not say bad input. It shows us the help. All right, last thing to do is take a quick look at it from bash and Caboose, and we'll run it on mix.exs. That is the last 10 lines. How about if we just want the last 2 lines? Excellent. Last 20 lines. Last lots of lines. Okay, at this point, I'd say it's fair to declare this a challenge accomplished. We've gotten our CLI working, and it runs natively from the command line. It handles all these various situations, and from this point, it's pretty straightforward how to add more and more functionality and just entirely clone the real tail, although that'd be kind of silly since the real tail is heavily optimized and it's written in C and so forth, but we've got the basic idea. If we want to make command line utilities, the performance is more than good enough for our personal needs. In doing this project, we had a good chance to reinforce what we've learned about making command line interfaces and improve our Elixir just a little bit. If you enjoyed the lesson, please click subscribe, click the bell, and I'll see you tomorrow.